Hi, I'm Don Welch for MTI Instruments, and in this video we're going to talk about MTI's new hybrid probe. The hybrid probe is used to measure thicknesses, paint thicknesses, film thicknesses on top of a metal substrate, and we'll demonstrate that in a second. What the probe is composed of is a stainless steel shell to hold everything together, and there's an MTI capacitance probe that's embedded in here, and there's a circular annular ring on here which is the capacitive part of the probe. In the center of this probe is an eddy current probe. So this is actually two probes in one, and that's why we call it a hybrid probe. So these two probes together can be used to sense, the eddy current probe senses the distance to the metal substrate regardless of what's on top of it, and the capacitance probe senses the distance plus any material that's on top, such as a paint or a film or whatever you might want to put on top of this metal substrate. And the difference between these two is the thickness of the material or non-conductor on top of the metal substrate. So it's important we have a grounded metal substrate, and we can measure non-conductive materials such as paints and films, etc. We have in the sample here, we have an aluminum sample sitting here that's got three sections on it. One is just bare aluminum, so we can look at the gap down to the base plate. And then we have a section which consists of 1/3 of the sample that's got a 20 micron thick paint sample on it. And on the far left here we have a paint sample that's 40 microns thick. And what we do before we start here is we calibrate the probe to a known thickness. So we could pick either one of these painted sections. We'd have to know ahead of time what the thickness of that is by checking it with a micrometer or such. And then we would program our software program that we use to measure the thickness with that known thickness in there, so we don't have to worry about what the dielectric constant of the material is. So that's a setup that there's a previous video that shows how to go ahead and do that. It's very easy. It takes about maybe 2 minutes to go through that process. So we have a motion stage here that's going to allow me to move the sample, and we'll be able to look at this statically and then dynamically. We have a controller here that moves the motion stage. We also have an amplifier, and there's two channels in this amplifier. One channel is for that capacitance probe, outside annular ring, and the other channel is for the eddy current probe. And the difference between those two, again, is our thickness of what we're trying to measure here. And we will look at that using our PC here running the MTI Accumeasure Measurements program. And there's a specific choice in that program out of maybe 12 different choices of different kinds of measurements we want to make. And that would allow us to use the hybrid probe to measure specifically the thickness of the paint. So what we're going to do is we're going to start this program running here. This is like an oscillograph. In the upper left-hand side, we can see the real-time thickness measurement of the paint, and it's reading 0 right now. And that's because our probe is sitting over the aluminum base plate here, and there's no paint on it, so we would expect the thickness to be 0. Now, as I start the program, we immediately go into an alarm condition. One thing I should mention is I set up the measurement system so that a reading of 0 would be the paint is too thin, 20 microns would be the paint is just right, and 40 microns the paint's too thick. So we also have alarm capability built into this program that can talk to an external board that's got a relay on it to turn a light on or sound an alarm if you have your process running and the paint thickness is not what you want it to be. So what we're going to do is we're going to jog the sample down to the 20 micron thick section. And if we look at our display over there, and my elbow just bumped the table, that's what that little spike is, we can see that we're reading 20 microns. And I have the cursor right here showing where 20 microns is on the vertical scale. Now as I move this to the 40 micron section, you'll again see that line is now going to jump up to 40 microns. All right, so we see the transition from the 20 to the 40 right there, and now we're looking at 40 microns. So that's a static demonstration of the paint thickness so we can see what it's doing. Now we're going to dynamically start this up where the stage will home itself so it knows where it is. And while it's doing that, I want to point out also, you got to have a ground on your system too. So that metal plate that's underneath needs to be grounded back to the amplifier. No big deal. All right, so what we're doing right now is shuttling the sample back and forth over from the 0 to the 20 to the 40 and back again. And if we look over at our display here, we can see there's the 0 section right there, there's the 20 micron section there, and the 40 micron section right here. Now, ordinarily, you're not going to see step changes like this. That's because our paint samples are discrete units to allow us to set up and make measurements, so it's obvious to us what's going on. Ordinarily in a process, this would probably be a smoother transition between the paint thicknesses as the process varies. And we can also see up here in the window the alarm turning on and off as we go out of range of the paint thicknesses we want to measure. So this is a nice little system. It'll run up to 4 kilohertz. Again, we're measuring non-conductive materials on top of a conductive material. So if you will, it's kind of a double layer sandwich. And it can be used to measure wet paints that you can't touch. So this is a pretty handy measurement technique to measure insulators sitting on top of conductors. And that's about it. If you have any questions, you can contact us at MTI Instruments, give us a call, or go through our website, www.mtiinstruments.com. We're glad to have an engineer talk to you about your application and answer any technical questions you have, or get a quote out there for pricing. Thank you.